So in the first example, a person invests $500, that's your lowercase a, into an account that earns 4%, so that's your R, 0.04. How much would this investment be worth in 10 years if it was compounded once per year? So N is just 1. So we take our 500, 1 plus 0.04 is our rate, over it's only being compounded once per year. And they want to know what is it worth after the time frame of 10 years, so 1 times 10. And this is straightforward on your calculator. 500, 1 plus 0.04 divided by 1, raised to the 1 times 10 power, $740.12. If, on the other hand, the interest was applied 4 times per year, quarterly, that would be used. That would be the word, the vocab word. Quarterly means 4. Same thing. I'm just splitting my 4% up into 4 parts. So rather than getting 4% one time, I'm going to get 1% on 4 different occasions. N is 4, and I'm still waiting 10 years. 500. Oops. 1 plus 0.04 divided by 4, raised to the 4 times 10 power, $744.43. Did it make a difference? Yes. Not huge. But the general rule is the more times you compound, the better it is for the consumer, the better it is for you. If you were told that an investment earned 4% per year, how much would you assume was earned per quarter? You would assume, and it might be wrong, 1%, 1%, 1%, 1% would be the assumption. Okay? Actually, that's not wrong. That is true. Okay? Using your answer from part C, calculate how much the investment would be worth after 10 years of quarterly compounding. Didn't we already do that? Oh, we already did that. I didn't read this question. Why would it not make sense? All right, don't worry about all these whys and explains. Compounded once per year, 10 years wait period would be worth that. Compounded quarterly would be worth that. The general rule, all you need to take away from this is the more times you compound, the better for you. This is asking us to write the formula. We already wrote it up top at the top of the paper. Exercise 2. How much would $1,000, that's your initial amount, invested at a nominal, that's just your percentage rate, 2%, 1 plus 0.02, compounded monthly, that would be a 12, to the N, which is 12 again, times T. We're waiting 20 years, it says. And we just type that in. Make Passo's got it for us all. That's okay. Bring up your calculator because this is worth probably pointing out because you won't be the only person that gets it. Let's see what he did. 1,000. Oh, it's 1 plus 0.02 divided by 12. No, only the 0.02 is being divided by the 12, not the 1. So when you type this in, it's just the 0.02 that's getting divided by the 12. So if you're going to do your alpha y equals, just do it on that portion. Does that make sense? $14.91 and 33 cents. Okay? So there's a nominal rate and there's an effective rate. So if you're going to get 12%, and I'll just use a generic example, compounded monthly, this is your nominal rate. Your effective rate is going to be slightly higher than that. I would guess, and it doesn't really matter exactness, I would guess somewhere around like 12.1% is effectively what you get. Okay, if it was just the nominal rate and you were increasing $100 by 12%, what would your final balance be? If you were just getting 12% of 100, what would your final balance be? Isaiah? You would get $12, so your final balance would be $112, right? So that's your nominal rate. You are given 12% one time, then that would be $112. The reality is, if this is compounded monthly, that's what you would really have at the end of the year. So your effective rate is you got $12.68, so your effective rate is 12.68%. So I just did it a little bit more exact. So I actually underestimated. So whatever your nominal rate is, the more times you compound it, your effective rate goes up very slightly. Doesn't make a big difference at the end of 1 year, but at the end of 20 years of investing, it'll make a big difference. Okay? All right. Let's just jump down to continuous. This one is just going to, exercise 4 has us do a quarterly, where n would be 4, a monthly where n would be 12, and a daily where n would be 365, unless it's a leap year, of course, 366. The idea is you're going to see that your final balance is going to be greater the more times you compound. That's all. Because that just means the more times you're going to make interest off of someone else's interest. You're going to make interest on what was not your money to begin with anyway. But then there's this idea of continuously compounding, meaning you are compounding every minute of the day, every second of every minute, which is a weird concept to wrap your head around. You're essentially going to be compounding infinitely. You're going to split up your 12% nominal interest rate an infinite number of times. It's a hard thing to wrap your head around. It has its own separate formula. And the formula is right here. I'm going to refer to it as the PERT formula, which is just going to be an easy way for you to remember it. So if you ever see the phrase compounded continuously, think PERT. That's P times E to the RT power. P is your principal investment, which is just like our lowercase a has been. Okay? So it's another formula, unfortunately. P is your principal investment. It's just like your lowercase a was, your starting amount. Your E is that new irrational number that we've been using. Your R is your rate. Your T is your time. So if a person invests $350 in a bank account, that's your P, your principal investment, has a nominal rate of 2%, 0.02 is your R, continuously just tells us use this formula. Write an equation for the amount this investment would be after T years. So your final amount after T years will equal $350 times e to the 0.02 times t power. How much would this be worth after 20 years? Plug in a t of 20. Okay, 350 e 0.02 times 20 power, $522.14. With money, hopefully you've picked up on it. It always makes sense to round to the nearest hundredth. Algebraically determine how long. So we're going to find t. It's going to take for this investment to reach 400. So our final amount is 400. Our initial amount is 350. And we're solving for t. And we've been solving these over the past week. What do we do first? Trying to get t all by itself. Divide by 350. I'm afraid of that decimal, so I'm just going to leave it 400 over 350. Our variable's trapped in an exponent. How do we get rid of the e? Natural log. Very good. That will cancel that. So we have the natural log of 400 over 350 equals 0.02t. And now getting t all by itself is as simple as dividing by 0.02. So it will take the natural log of 400 over 350, close that parenthesis, and divide that answer by 0.02, 6.7 years. So 2 new formulas added to your list.